All right, so in the last video, we had some nice triangles. Angle, side, angle, and angle, angle, sides. These triangles, you just solve them exactly like how we solved them. And it's relatively straightforward as long as you know how to apply the law of sines. Well, in this video, we are going to have side, side, angle triangles. Sometimes they're written in the opposite order as well. You can also call these angle, side, side triangles, which I think would be more appropriate because these triangles are bad. These triangles, SSA, ASS, however you want to spell it, are loads of fun. Because essentially there's 4 things that can happen with one of these triangles. And we solve it differently in 3 out of the 4 ways. So there's 4 possible outcomes for these triangles. 4 possible outcomes for ass triangles. Side, side, angle. Angle, side, side is the same thing. And it depends on how big that A is. Because the whole thing about angle, side, side triangles, right, is that we know an angle, alpha, side, and another side, right? Angle, side, side. But what if I give you an A? What if I give you an A that's less than the height of the triangle? Think back to that triangle we started with at the beginning, right? This was the height. Well, if this A is less than that height, there's no triangle that can exist. If A is less than that height, it's impossible to draw a triangle. There's no solution. So if you're given a description of a triangle where that A value is too small with angle, side, side, there's not going to be any solution because that A just can't reach. Like, there's no triangle to draw because the A can't get far enough. Okay. And if A is the same exact thing as the height, well, then we have one solution. That's good. This is a happy situation. All right, if A is exactly the side of that height, then it reaches all the way down. This is still alpha, this is still B, this is A. And specifically, if A is equal to H, then we have a nice right triangle. This is the rare happy case. Rare happy case. The math in a nutshell, right? So what if A is bigger? Well, if A is bigger than H, but still smaller than B, remember this is B. So A is big enough. So A is longer than this. A is actually like this long now. That's the real bizarre case. Because if A is too long, right? So we still have the B from before. I don't know how long this bottom side is. But if A is long, I want to make sure I get this picture right. If A is long, well then sometimes it can swing this way to represent that possibility. This could be A right here, but sometimes it's long and it has to swing the other way. That's also A. If A is long enough, we have 2 triangles because, again, if this side is too long, we have to either swing it to the left or swing it to the right. And it just changes the value of C. But the A, the B, and the alpha are still the same. Okay, so it's possible to have 2 solutions here. You get to solve 2 triangles. These are going to be really fun. And if A is just really big, right? If A is even bigger than B, then again, we have a nice situation. Only one solution. Right? If A is bigger than B, then this one doesn't exist anymore, right? As A gets bigger and bigger, this gets closer and closer to here, but if A gets bigger than B, then like we can't swing past here. In this case, if A is really big, and it only just looks like this. All right. So this one is actually really nice because as soon as we find there's no solution, we just say no solution. This one, that's messier. The more fun. You get to do some more math. So be on the lookout for this. If you can spot this, that's great. If you can spot this quick, that's great. If you don't really want to worry about which case, it'll pop up with the math. All right. We're splitting this video up into 2 parts because it's a lot of stuff. All right. First part, we're going to look at one of these cases, one of these outcomes, and I'm not going to tell you which one it is. All right. Example 3. Solve the triangle with alpha is equal to 35 degrees, A is equal to 6, and B is equal to 8. So if we went off to the side and figured out how big H was, we could see which case we were in. Right? If we went off to the side and knew what our H was, that would tell us which one of these. We know we're not in that last case because A is not bigger than B. Right? A is smaller than B here. But why go to the work to find H? Let's just solve it and see what happens. So I'm going to draw a picture, and this is kind of a fake picture. A picture not drawn to scale. Because there might not be a triangle. There might be 2 triangles. We don't know. So I'm just going to give a visual aid of a picture. So alpha is about 30 degrees. That's 35 degrees. And A is the opposite side. And B is going to be over here. Let's say, I don't know, maybe it looks like something like this. This is beta. This is gamma. We don't know beta or gamma. We do know that A is 6 though. So we're going to approach this just like before. Okay. How do we start? We pick a pair of angle and opposite side that we know. In this case, A and alpha. And use the law of sines. Sine of 35 degrees divided by 6. And now we pick a pair that we don't know. This pair would work. This pair would not. Right? We don't know what C is. So we're going to have to choose this pair. Beta and 8. Equals the sine of beta divided by 8. So right off the bat, you can see what's different about side-side angle triangles. Right? This gives us 2 sides and only 1 angle. In the last video, those other triangles, we knew all the angles immediately because they add up to 180 degrees and we were given 2. But here we have to solve for these angles with the law of sine. Z. And sine, we're going to have to solve for that sine. We're going to have to solve a trigonometric equation. We just did that in 9.5, right? Solving trigonometric equations. Great. Let's solve for B. So we get 8. We get 6 times the sine of beta equals 8 times the sine of 35 degrees. Keep things exact as long as you can. We'll approximate later. Or that the sine of beta is equal to 8 sine of 35 degrees divided by 6. That can be reduced, but we're going to be approximating here anyway. Okay, so remember there's an infinite number of solutions to some trig equations, and there's no solutions to other trig equations. Let's see what this is. If there's multiple solutions, that's going to be multiple triangles. If there's no solution, that's going to be no triangles. If there's one solution, that'll be nice. It's not going to be very likely. It'll be nice, but that'll mean there's one solution. Okay, so remember, may have multiple answers. Multiple or no answers, just like we did in 9.5. Now, we don't have to worry about negative angles or angles that are bigger than 180 degrees. We only have to worry about things in the first and the second quadrant. So, what reference angle, again, going back to 9.5, what reference angle gives us this behavior? Well, that's going to be the inverse sine of 8 times the sine of 35 degrees divided by 6. That's going to give us our reference angle. Type that into a calculator. We're looking at the inverse sine of 8 sine of 35 degrees. Make sure to have degrees. Divided by 6. And Google is going to give you something in radians. So convert it to degrees. 49.8864. Our final answer is probably going to be rounded to a single decimal. But this answer, we're going to want more decimals because we're going to have to use it later. So the question is this the only answer? Well, remember, if the reference angle of about 50 degrees, well, it could be in the first quadrant, but it's also positive in the second quadrant. All right, this right here is beta. But maybe this thing over here could be beta too. So if beta prime is something that makes sense for this triangle, then we're going to have two triangles. So does beta prime make sense? What is beta prime? It's going to be 180 degrees minus that reference angle, which is about 49.8864. So beta prime, if it exists, would be approximately all of this 180 degrees minus this angle, which is, why is it so upset? Did I mean that? Sure. All right. 180 degrees, Google is failing me. Minus 49.8864. 130.1136. Does this angle make sense? And what we're going to look at here is two things. Right? All the angles in the triangle, the angles have to add up to 180 degrees. So if beta prime exists, can we still add to 180 degrees? If beta prime were 160 degrees, for example, right? 160 degrees would be impossible, right? Then we're already over 180 degrees in this triangle. So 160 degrees wouldn't work, but 130 degrees does work. Right? So we have this. Yep, check mark. We can have all of our angles add up to 180 degrees, no problem. What's the other requirement? The other requirement is side ratios. All right? Is B the biggest side? Because beta is the biggest angle. Beta prime is the biggest angle. So is B prime the biggest side? Include that prime there. Well, so far, yeah. B prime would be the biggest side. So in this case, add another check mark. Both beta and beta prime make sense. We have two answers. All right. One with a big angle for beta, one with a small angle for beta. So this is our triangle for beta. That's the acute angle. Beta is about 50 degrees, but there's another triangle as well. But now there's a second triangle with alpha, same gamma, but now beta prime. Now notice C is much shorter, right? B is still the same, and A is still the same. We're gonna have two triangles here. And again, the two triangles, this is tricky to find. There's a lot of ways of approaching this. You can calculate H. Again, if you calculate H, you can figure out exactly which situation you're in. Or you can do this little checkbox when you're solving for your first angle. And if they're both satisfied, then yeah, beta prime makes sense. We're going to have to use a second triangle. All right, that's what's going on here. And that's why we're doing two videos for this situation, because it's much more tricky. Also, check out that selected homework problems video as well. We talk about this some more in there. Okay, so beta. Beta is 49.9 degrees about. Beta prime, 130.1 degrees. Fill in these triangles. This is still 35 degrees. And again, as soon as we find beta prime and beta, well, now we can find gamma and gamma prime. Oh, sorry, this should be a prime right here because it's not the same as gamma. So we use a calculator. I have to go to the next page. So gamma, it's just going to be 180 degrees minus alpha, which is 35, minus beta, which is 49.9. Type that into a calculator. Oh, again, technically this should be the approximate. And this will be equal 180 minus 49.9 minus 35. Going to be 95.1 degrees. Gamma is 95.1 degrees. Similarly, we can find gamma prime. Right, gamma prime, it's 180 degrees minus 35 degrees minus beta prime. Beta prime is much bigger. Keep tabbing incorrectly. 130.1136. Which again, we're only rounding to the single decimal place here. If you type that all in, 130.1 is fine for this. 14.9 degrees. Gamma prime is much smaller. And you can see that in the picture I drew. 14.9 degrees. Oh man, I can't draw that small. Should have made my triangles bigger. 14.9 degrees. So both of these triangles, they add up to 180 degrees. All that's left is solving for C. Whew. All right, let's solve for C. So we need to solve for C and solve for C prime. And in both of them, we're going to use the law of sines, choose an angle and its opposite side that we know. Angle and opposite side. So we're going to choose alpha and A for both of them. We could choose beta and B, but one, then we have to worry about primes and not primes. And two, it's always best to use exact numbers. These ones were given to us. We know them exactly. We don't have rounding error. Let's use sine of 35 degrees. Same ones we used before. You're going to use law of sines multiple times. And then 6. You can use the law of sines multiple times in these problems. Always start with the same exact pair. As soon as I write that here, we're going to use that every time we use the law of sines, like our foundation. So for C and for C prime. So this is going to be sine of gamma divided by C. And this is going to be the sine of gamma prime divided by C prime. We may as well solve these in parallel. We're doing the same thing, just with one is with gamma prime and one is with gamma. So gamma is about 95.1. Okay, we're going to get a little rounding error. It would have been better if we used more decimal places, but I'm not going to force you guys to do too much. 95.1 degrees is gamma. Gamma prime is about 14.9 degrees. Again, follow these same steps that we've been doing for a while. You're going to get that C is equal to 6 sine of 95.1 degrees divided by the sine of 35 degrees. And likewise, that C prime is going to be 6 times the sine of 14.9 degrees divided by the sine of 35 degrees. Type these into a calculator and you'll be good to go. So we go over here and say, okay, what is 6 times the sine of 95.1 degrees divided by the sine of 35 degrees? You're going to get about 10.4. And if you just change that top angle to 14.9 degrees, you have the same exact calculations for the other one, about 2.7. So C is 10.4, C prime is 2.7. And again, this makes sense, right? We're swinging this side, we're swinging this over to get to that prime triangle, so C does get much smaller. The bottom side gets much smaller and we swing that side over. So let's check. So we have all the information in these triangles. We should have drawn these triangles bigger so it's not so cramped. Let's do some double checks. The biggest angle should be opposite the biggest side. Good for that triangle. Biggest angle, biggest side on this triangle too. Let's check the smallest ones. Smallest angle should be across from the smallest side. Good. Smallest angle should be across the smallest side. Good. It's a big mess. We'll do some more on these in the next video. Stay patient, ask questions, get some practice, and you'll be able to survive. This is the worst part. This video is the hardest material in this section and the next section, as a matter of fact. So please don't get too frustrated if things don't make sense or are hard. Feel free to rewatch parts, look over the notes some more, ask me questions, ask other people questions, but good luck. You got this.